The following content is for entertainment and educational purposes only. It does not constitute means for diagnosis, healthcare advice, nor treatment. Make use of a qualified healthcare professional for such purposes.
Hello, everyone. My name is Dr. Charlene Ortiz, and today we're going to start a new topic. Today, we are going to talk about the experimental design, particularly geared towards a within subjects experimental design. We have previously talked about a between subjects experimental design, and I will have that linked in the description below. And today we're going to cover another aspect that is somewhat similar to the between subjects design. So let's get started. Right. So as I mentioned, it is a little bit similar to the between subjects design. And because of that reason, I have decided to continue and present this particular subject. So as you know, you guys are good researchers. So one of the things that we have to do is define what a within subjects design is. Basically, what we're trying to do is that we are going to observe the same participants in each group. Notice that in our between subjects design, we had different participants, right? We had different participants. And here, what we're trying to do is within the subjects, right? We're looking for those observations within that same group and not necessarily with group A and group B, like you would in a between subjects, but in a within subjects, there's no group A and B, but we're only going to observe the one group. So that is the main definition that I would like to present to you guys concerning a within subjects experimental design. Notice that in this particular design, we may have different reasons. We may have different reasons as to why, I don't want to observe different groups, right? I want to observe the same group of participants. And there are several reasons. The first one is because we are interested. We are interested in managing the sample size. We may have a sample size that may be too large. It is more practical. And it will be easy to observe the same participants in each group than if we had a lot of participants in separate groups. So that's one of the reasons that we like to keep it in a within subjects experimental design. Now, a second reason why we would be interested in observing the same group of people, it's because we might be focused in looking in changes over time, right? We are interested in observing how the same group of participants can change over time. So notice something really interesting could be you have a case study, right? So you want to observe the same people, that same individual across a significant amount of time. So that's another reason why you may not be interested in observing different groups at the same time. Now, the issue that we're going to come across a within subjects experimental design is one of the largest limitations, which is lack of randomization, right? If you remember from our previous type of design, you'll remember that we were able to assign participants randomly, right? So not only were we able to come across and gather, right, and collect that sample randomly, but we were also able to, from that sample, assign them randomly to group A and assign them randomly to group B. However, here, the situation is, because I am observing the same group, I am not able to randomly assign the one group to separate groups. So now I have a lack of randomization. I am not able, it is not possible to conduct a random assignment. It is not possible. Because of that, because I am lacking one of the main criteria to show cause and effect, which is, if you recall, having a manipulation of independent variable, having the ability to randomize, and having the ability to control. Notice that because I am unable to randomize, that tells me that this particular design cannot demonstrate cause and effect because of that lack of randomization. Any questions so far about what a within subjects design is, what we use it for, and its potential downfalls? All right, good deal. Fantastic, fantastic. So let's revert back to our presentation. If you remember, very similar to our between subjects, we do have very similar steps. We have very similar steps when it comes to the within subjects design. Now, something that I do want to mention, right, very, very quickly is the first thing that we do is obtain a sample, right? We will have different levels, right? Different levels in which we're going to manipulate our independent variable. Notice that one of the main differences is when we move towards step 3, right? And in step 3 for our between subjects, we talked that we have different participants in each group, whereas here we have the same participants in each group. Another significant difference is that, remember, we had issues with that randomization. So let's focus on our step number 4. We're trying to control for some limitations that may come either from the order in which we present the situation to our participants, or limitations that can come from time-related factors. So this step here is super important. It is very significant because we're trying to keep the control as much as possible. Remember that step 4 is included as an added measure of control, right? For possible issues, say for instance, in the order. And we're actually going to talk about issues that come from control and issues that come from time-related factors. So if we revert back to your presentation along step 5 towards the left of your screen, you'll notice that just like in your between subjects that we learned previously, you are interested in measuring, I should say, the same dependent variable. You are observing the same variable. Now, one of the last things that we're going to do with your within subjects, I should say, is step 6. And here, what we're trying to do is use inferential statistics. We're going to compare the differences that we have observed. And lastly, the last step that we would consider is making a decision, as to what can be indeed inferred from our data. What can we actually do with that inference that we have come across? So any questions about the steps of a within subjects design and how is it similar and or different to a between subjects design? All right, fantastic. I'm going to start adding hashtags at the top of the screen on the videos, like fantastic, 3 A's and 3 N's, because I'm special like that. All right. Now, as I mentioned, we are going to have issues with control, right? We're going to have issues with control because we are using the same sample, right? We're using the same exact people. Notice that one of the first issues that we're going to come across is time-related factors. When we are required and it's indeed feasible to start controlling for those time-related factors. When I am talking about time-related factors, notice that these are factors that a participant that can be observed and can vary over time. So think about you as a student, right? Think about you as a student. This here could be considered a within subjects design. And you're thinking, well, how is that? So you and I have been working together, learning from each other for the last couple months. But notice that I have observed the same group of participants. And if I wanted to compare you guys, say, for example, how much did you know about research at the beginning of the semester compared to how much you're going to know about research when you take your final or when you do your poster presentation, notice that that would be considered within subjects because I am observing the same group of people, and the dependent variable in this case would be your knowledge about research. But what would happen if, say, I am comparing you guys from this section of research, and then I compare you guys with another research class, right? Another section. That's what we were referred to as a between subjects. We're still measuring the same variable, which is your knowledge about research. But notice that now I am doing a comparison, right? I'm doing a comparison between group A, which would be you guys in my section, and say another section, right, that I would be teaching. So that is a little bit more aligned with the between subjects design. But here, you will be considered a within subjects. And why do I mention that? Because there might be issues with you just being able to know more about research because just time went by, right? Not necessarily because of my delivery, not necessarily because of lab, not necessarily because of practice quizzes, but rather because it was a time-related factor. Say, for instance, you would be able, right? You would be able to control for this factor. Let's say, let's think about participants, in this particular case, covariance, right? Covariance. When I am referring to covariance, notice that there could be a factor that not only that variable is not affecting that variability, right? That variance within the subject, but there may be another variable that is co-affecting the ability for me to measure, right? That is why this covariance can become a threat to internal validity. How do I exactly know that I am measuring what I'm trying to measure if there is a co-factor, right? So for instance, let's think about here in the classroom. I'm thinking that that variable that is affecting you guys is my delivery, right? The delivery of the class. But say, for example, you start going to tutoring for the research class. Notice that now that factor is going to co-vary. It's going to cause a variation with your knowledge. So it wasn't me necessarily that affected your knowledge of research, but rather a covariance, an interaction between that tutor and myself, then with the knowledge that you may have about this class. Notice that just like in the case of between subjects, notice that we also have to control for this factor here. Now, I want to give you, right? I want to give you a couple of examples, right? A couple of examples. And as you know, we have talked about maturation as one of those factors that could contribute to time-related factors and that measurement. In previous lectures, we have talked about maturation. And notice that it's simply your experience, right? Your experience, your development, it's simply going to affect my measurement, right? That variability with my variable. Another thing is the aspect of testing effects. And some of you may be familiar with testing effects. And what does that mean? Well, sometimes when we are exposed to the same test, one of the few laws in psychology, by the way, that we have is that if you take a test today, chances are, even if you didn't study, chances are that when you take it next time, you're going to perform better, right? That's one of the few laws that we have. Notice that this is an example of testing effect. You have already been exposed to the items, to the stress that may come from an assessment, and notice that because of that, you may be able to show a different measurement, i.e. getting a better grade in the test. because simply of that test exposure that you had. And lastly, what are the things that could be related to those time-related factors that can impact my control? Notice that we have participant fatigue, which in classes like this one, for example, research like, whoo, I am so tired of taking this class, right? And hashtag relatable, right? It is hard to take a research class. So notice that the individual can become fatigued, right? So for example, providing many assessments, maybe the assessment is long, maybe the process does take a long time for the person to conduct that measurement. So notice that yes, the participant can indeed become fatigued, and therefore that time affects the measurement of my variable. Perhaps you know a lot about research, but because the exam took 3 hours, maybe that's not going to be a good reflection of how much you know. So that's why the time in which we offer a test is significant. So any questions about that? Fantastic. Good deal. Now, as I mentioned earlier, right, another factor that we have to control over is not just the time-related factors, but also the order factors. That's also an aspect that will affect my within subjects design in my step 4. So we just talked about time-related factors. Let's talk a little bit more about order effects. Notice that in order effects, what causes the changes in the dependent variable is not the treatment, right? What caused the changes in the dependent variable was the order of your participation, right? And this is immensely significant because if I present to you something in a different order, it may affect the score. It may affect that measurement. It may affect that assessment of that dependent variable. Notice that when I am referring to order effects, I am also referring to a threat in internal validity, just like I mentioned with the time-related factors, right? So it's the same thing. It is still a threat to internal validity. Notice that this relates because of the different order, and I can provide a treatment. So there are multiple issues, right? Multiple ways that I can engage in order issues. So for example, maybe the order that I present those questions to you affects your results, right? So some people prefer, let me do the tough questions first, and then I'll leave the easier ones last. Or vice versa, when you take an exam, say, let me do the easy one first, get them out of the way, and then I'll do the hard questions, right? So notice that because you are taking those questions, because you're trying to respond to these questions in a different order, it can affect your responses. So imagine if I'm doing that within an example of a within subjects experimental design. It will affect the order that I am engaging in and that I am presenting these items can indeed affect the results that I can find. Any questions about that? Now, another example of order effects, notice that we also have carryover effects. In this particular case, what happens is that if you were to participate in one group, that's later going to affect your performance in the second group. So what does that mean? Notice that if I ask you to complete a task, so for example, I give you a puzzle and you guys belong to the puzzle group, and I tell you guys, okay, finish the puzzle. Now, the second time, it's going to be affected because you already know what to expect. You already have the knowledge of what it is that I have to do, right? So if you've already been exposed to that puzzle, notice that the second time you do it, you're going to have knowledge. Therefore, it's going to change your performance. That is also a concern for internal validity, because am I actually measuring your ability to solve the puzzle, or am I measuring your ability to recall how to solve that puzzle? So yes, it is a threat to internal validity. So any questions about that? Fantastic, good deal. Now, notice that I said that these are threats, but generally when we are talking about threats in research, our job as researchers is to attempt to control them, Now, there are some things that we can do in order to be able to control for these factors. Now, one of these is the ones that we like to refer to as counterbalancing. What we're trying to do is either balance, right? We either try to balance or offset. We're trying to balance or offset the order in which the participants are going to receive different treatment, right? And what does that mean, right? What does that mean in a very basic sense? So notice that what I'm trying to do is if I have, for example, a participant A, and they're being exposed to treatment 1 and treatment 2. And participant B is then going to be, again, exposed to treatment 1 and treatment 2. What I could do is offset that participation. So for instance, participant A is going to be exposed to treatment 1 and treatment 2. But then participant B, I'm going to show them treatment 2 first, and then treatment 1. So notice that instead of 1 to 1, now it's offset. So now I can do 1 to 2. So that's what we refer to counterbalancing, right? We're trying to prefer, or I should say offer, either balance or offset the order in which these participants are receiving different treatment. So there are these potential strategies that I can use to address issues with time-related factors. Now, something interesting that we can do is that there are two types of aspects for counterbalancing, right? And the first one is a complete counterbalancing. And what do I mean by that? What I mean by that is that I have considered all of the possible orders, right? All of the sequences that I can engage in, right? So I am able to do all of the possible measurements to address the sequences of that offset. Generally, we do not like to do this with large groups. Generally, the only time you do a complete counterbalancing technique or strategy, it's whenever you have no more than 3 groups, because more than that, it would be immensely difficult, right? Immensely difficult. Now, we can calculate how many, what is the possible order of sequences, right? So this is when we are going to use kappa. Kappa, it's simply the calculation of the number of treatment of the groups. And with our symbol here, that simply means the number of order of sequences, right? So we have the number of treatments, and so the number of treatments illustrated with kappa, and then our number of possible other sequences. Notice that the combinations could get very complicated. Think about when you're shuffling a deck of cards, right? How many combinations can you have? Well, it's the same premise here. You may have a lot of offset. So that is why we like to limit it to only and no more than 3. No more than 3. So any questions about that? Any questions? Fantastic, good deal. Good deal. Now we saw one type of counterbalancing. Let's look at a partial counterbalancing. Notice that conversely, or contrary, I should say, to all of the order, all of the possible sequences that I may have for this order, notice that I'm only going to use some, right? I'm not going to use all of the possible combinations, but rather just a few. Notice that contrary to our complete counterbalancing, in which I'm only going to calculate all these possible combinations, just like you would with a deck of cards and all the combinations of shuffling you would have. Notice that here we were only doing it with a small number. However, with partial counterbalancing, notice that here, because I'm only looking at some of those order sequences, notice that I can use it for more groups, right? So 3 or more groups. Now, to ensure that we actually do have a representative order of sequences, notice that we could use different methods. So for example, each treatment group will appear, right? Will appear, right? So we're not trying to isolate each group. We don't want it to be just because we're showing a specific combination doesn't mean that the frequency is going to change. We do want to see those combinations, right? We do want to see the presence, that frequency. And also, another characteristic to ensure that my sequences are representative is that each group precedes and follows each group once. We don't want a repetition of these groups. I don't want to be that the shuffling, I don't want it to be that group A appears and then group A appears and then group A and then group B. We want it to be basically preceding and follow each group one. So we wouldn't want it to be B, 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 and A. We want it to be a relatively nice combination. So for example, I want each group to precede the group that it was followed. So any questions about that? Fantastic. Now we do have some special cases. We do have some special circumstances. And that is when we have a Latin square. A Latin square is simply a form of partial counterbalancing procedure, and it's generally used to select an unbiased set. It's usually utilized in order to have a procedure that is unbiased, that we don't have a set particularly geared towards that combination, but rather it is unbiased. And it's generally used when it is difficult to counterbalance all of the potential sequences. Notice that in order for this process to be unbiased, right? So for example, you don't have a preference of BB, BBA, and then you keep finding yourself with that sequence, you would use the Latin square. Now, in order for that to function, in order for that to be functional, notice that there are some rules, right? There are some rules in order for an individual to conduct an unbiased order of sequences. The first one is that the number of order sequences equals the number of treatments. So for example, you don't want the order of sequences to be, say for example, 7 when you only have 2 treatments, right? You want them to be exactly the same. Another characteristic in order for us to have an unbiased method for order sequences is that that treatment appears equally as often as in each position. So notice that I am not going to present one treatment in favor of the other. Each treatment is going to follow and it's going to be equally as present in each position, right? So one treatment is not being more favorable than the other. And the last characteristic that we want to look into is that each treatment precedes and follows each treatment one time. Just like we had mentioned previously, right? Of that precedence and that follow through after each group is present. The same goes here. The same goes with our Latin square, which is each treatment is going to precede the other treatment. So any questions about that? Notice that if I present to you a response or a treatment, I should say, that is unbiased, I am guaranteeing that one is not going to be more favorable than the other, right? So that each treatment had the ability to be presented rather than me as the researcher leaning towards, let me present treatment A because I think this treatment is going to work better, or vice versa, right? I think this treatment is going to work worse and I'm trying to show that my treatment works. So let me present it often. But notice that if we're trying to do unbiased counterbalancing, notice that these are the rules that we should follow. So let's move on to a really nice illustration when it comes to counterbalancing, what that would look like in our actual within subjects example. Notice that, as I was mentioning earlier, notice that you have participant A, right? So we have participant A. Notice that without counterbalancing, right? When I am not offsetting or balancing by treatment, notice that participant A is going to be exposed to treatment 1 and then treatment 2, right? And treatment B. And the same, right? So for example, we have our second participant, participant B. He is going to be exposed to the first treatment and then the second treatment. Notice that when we use counterbalancing, notice that in this particular case, about half of those participants in the group experienced treatment A first and then treatment B. So for example, in my first one, participant A, in a counterbalancing aspect, notice that participant A was exposed to my first treatment first, and then my second treatment, treatment B. But notice that my second participant was not exposed to treatment A first. It came in second. And now I'm going to expose him first to treatment B and then treatment A. So notice that in this case, sure, we can argue that all of the participants are being exposed to the treatment. But notice that if I really want to guarantee that it was the treatment and not a time-related factor, I want to mix these up, right? Because I want to control that it wasn't a time-related issue, right? I want to control for that factor, which is why some participants, about half of them, are going to have treatment A first, and about half of them are going to have treatment B first. So that way I am balancing out the treatments instead of it being linear, and perhaps that time is what actually caused my dependent variable measurement and not the actual treatment, one first after the other. So any questions about this particular illustration? Any questions so far? All right, good deal. So in keeping with our illustrations, notice that now we're going to look at something very similar, but in this case, we're going to do an unbiased, right? We're going to look at that kappa. Notice that this would be all of the possible sequences, right? All of the possible sequences that I can show that treatment, right? So if you recall from our previous slide, remember that one of the things that I'm trying to do is I do have an aspect. Remember, this one's partial. So those are all of the sequences. However, what I'm trying to do is simply have a representation of all the possible sequences. So I'll give you an example here. Notice that I can present those sequences illustrated in letters. So for example, A, then comes B, then comes C, then comes D. But notice that another combination I should say for that sequence is A, B, D, C, and A, C, B, D, and so on and so forth. So notice that these will be all the possible combinations for this particular sequence. However, remember that this one is partial. So I'm not going to have the opportunity to do all these, but rather I am trying to grab a partial, right? A partial representation, a partial order of sequence. So notice that I'm only going to grab just a few, right? I'm only going to grab some, but not all of the sequences. So notice that in this specific case, you as the researcher, you found out how many combinations you have, but rather, okay, let me pick just a few that represent these combinations, right? So notice that if we revert back to our sample, notice that in the first participant A would be exposed to say A, B, D, C, and then say, for example, our second participant B, will be exposed to another sequence, treatment B, C, A, D, and so on and so forth. So notice that the combinations will be a little different. This increases the chances of me being able to say it was the treatment rather than time passing by, what contributed to my measurement of that dependent variable. So any questions about that? Good deal, good deal. All right, so in keeping with controlling for effects, let's look, or I should say time-related factors. Let's move into our presentation and notice that whenever we are controlling with time, remember that previously we were talking as to how to control for that order, right? Counterbalancing with or without. Let's focus a little bit more in controlling time. Now, we can, for example, control for the interval, right, between the treatments or groups. So notice that what I'm trying to do, if I am able to control and maintain consistent that interval, notice that I am able to minimize those carryover effects. And I'll give you an example in the Queen's English, right? So what does that mean that I control for the interval, right? If you recall, we just mentioned that carryover is that you are exposed to this particular treatment and then you continue to remember, right? You continue to have knowledge and carry it over to your second exposure. Some of you may know that whenever you take a driving test, or say, for example, a licensure exam, notice that when you take it, say, for example, you failed, right? You failed your driving test or you failed, say, for example, a licensure exam. Notice that they won't let you take it after a certain time has passed, right? They will tell you, you can retest, but you can only retest in 6 months. And why do they do that? They are trying to control for timing. They're trying to ensure that there is an interval present that is intended to minimize those carryover effects. They don't want you to take that exam tomorrow because you're going to remember what was in the test, right? So am I truly testing you in your ability for licensure, or am I testing you in your ability to remember what you did yesterday, right? So notice that that's one of the reasons why sometimes whenever we take an exam, you'll see that there is a time frame that they will not allow you to take that exam. Because am I truly measuring what I'm wanting to measure, or am I simply measuring your ability to recall what was in the exam yesterday? We do the same with psychological assessments. So for example, if you take a test, or I should say a psychological assessment, and say during this particular time, you took an intelligence assessment, maybe the practitioner is not going to be okay with administering that intelligence assessment within 3 months, within 6 months, because am I measuring your intelligence or am I measuring your ability to recall the items that were present in that assessment? Any questions so far about addressing the interval as a control measurement? All right, good deal. Notice that another issue is, remember, we're going to have fatigue. So remember that another aspect that is within your realm, within your control, is to minimize those demands that you place on your participants, the demands that you place upon them. So notice that for some individuals, some assessments can be 100 items long, 300, 600, like the MMPI. The MMPI is to the closer range of 600, right? And notice that that can cause participant fatigue, but it is your responsibility in order to control for those time-related factors to minimize fatigue. Because if you are fatigued, my ability to measure that dependent variable is going to decrease. You can be the most knowledgeable researcher on the planet. And I gave you an example about research this Friday, but if you're tired when you're taking this exam because it's so long, what are the chances that I'm going to measure your ability to know about research, right? So it's going to be pretty slim. It's going to be pretty slim. Now, notice that part of your responsibility Part of your responsibility is to minimize participant fatigue. Minimize participant fatigue. Why is that important? Well, the reason that's important is because with fatigue, there could be risk, right? There could be risk associated with your participation. So remember that, say, for example, you're trying to conduct a study and the individual is fatigued because of your study. Say, for example, you ask many questions to measure that dependent variable. Notice that now this individual is going to be fatigued, and therefore there could be consequences for this individual being fatigued. Now, how do you address this ethical concern? Well, of course, one of the first things that you can do is minimize that duration. Minimize that duration. Also, you may be able to allow for rest. You may be able to allow for rest. The only issue that I can see with allowing, I should say, a rest interval is that it may or may not affect that measurement of that dependent variable. Although we have assumed that because you are able to rest, then you have the ability of, let's say, for example, being able to refresh yourself, and therefore that measurement of that dependent variable is going to be a little bit more accurate. So that is the argument, because you're allowed to rest, therefore it's fresh, you're feeling better, and therefore the assessment is going to be conducted in a better fashion because you're not fatigued. And of course, that can come with other aspects, of course, but it's one of the recommendations to reduce ethical concerns. So any questions about that? All right, so if there are no questions, let's move towards our next aspect that could incur in aspects of variability. So we have covered up this a little bit before within our between subjects design, but I do want to give you a quick reminder, a quick refresher. We did talk about individual differences. We spoke about individual differences. Notice that individual differences, as we have mentioned before, individual differences are simply those characteristics that you bring to research, right? Those characteristics that you, in fact, have brought in. So, for example, trauma history, your gender, your race, those are things that I could not assign to you. However, those are things that are indeed going to contribute to research because they could have some variability. So imagine in the example that I was giving you about this is my within subjects design, and how, say, for example, I want to measure at the end of the semester your ability to understand research. So notice that perhaps your age is going to be a factor that could impact your exam. Your gender could be a factor that impacts your exam. Your socioeconomic status could be a factor that impacts your exam. The same thing happens with research. Characteristics that you come in with our research can indeed affect that variability, can indeed affect those factors that I am trying to measure. I want to ensure that my variability comes from that manipulation of that independent variable. But the problem is that individual differences can indeed contribute to that variability. I need to remind you that it will always impact it, right? That's why we have measurements of error, right? Your individual characteristics are indeed going to affect that measurement of that dependent variable. But nonetheless, we do account for that error. Notice that something that occurs with the within subjects design, notice that because we do observe the same participants in each group, notice that the individual differences are going to remain the same, right? The sources are going to remain the same. Those sources of variability are going to remain the same because I am indeed observing the same group of people. If you remember, from a between subjects, we had that sample, right? And I'm going to split it between group A and then group B. So the differences between these groups, say, for example, this group has more females than males, this group has people with trauma, and this one does not. notice that because of those individual differences, they are not going to be the same, right? They're not going to have the same variability. However, you have to control for those aspects. Now, within subjects design, we have that sample and they're going to be exposed, they're going to have the same group, right? We're going to do the same observations, therefore, those individual differences are going to remain the same. Now, we are talking about individual differences as they are a source of variability. Now, remember, in the sources of variability, let's talk about the sources of variability when it comes to between groups, right? So something interesting about that is that within the subjects design, we can measure indeed those differences as between persons variability, right? Between persons variability, which we are trying to measure. What we're trying to measure is the mean differences between the group's variability. We're trying to measure if in the participant responding to that particular effect. So notice that we can do this type of measurement, say by looking into between groups variability. Now, you heard me use the term error, right? You heard me use the term error. When I am referring to error, what I am talking about, an error is any source of variability that did not come from that independent variable. That's what an error is, right? Any source of variability that is not attributed to the different treatments, right? It's not attributed to that exposure. As I mentioned, for example, a source of variability could be, for instance, right, in the time, the age that you have. So for example, if you're older, if you're younger, that age difference can be a factor of variability. Now, remember that something really interesting about the within subjects is that in the sense of error within groups variability, notice that we should equate it to 0. We should equate it to 0 because notice that the differences will be the same because they are the same participants. It's contrary to that of the between groups where the participants are going to be different participants that are being observed. So let's look at an illustration of the previous example that I just gave you. Notice that here we have two potential examples. Notice that here we have the within groups variability towards the left of your screen. Notice that towards the right, we have between persons variability. So this section here. Let's look at them individually for the moment. So notice in the within groups, these differences are going to occur even though all of the participants in each column, so for example, the participants here and the participants in your second column, these differences are going to occur even though all of the participants in each column experience the same manipulation. So notice that the participants here did experience that manipulation when it came to treatment Q and treatment C. But notice that when we're looking at those differences, notice that they indeed were similar, they were different. So for example, here we have a score of 2, and here we have a score of 4, even though they experienced the same exact manipulation, right? Because we have different groups. Now, if I capture your attention towards the right of your screen, let's look at that between persons variability. Now, notice that in this case, differences, as it states here, differences are going to occur between the participants, right? Between the participants. So notice that here, it's not as a column, right? So notice that here is within that same participant, that same treatment, but notice that here, instead of a column, It's actually horizontal. And why is that? Because I am looking at the differences between the participants, right? Between them. So notice that these differences here that I am observing could generally be attributed, as stated here, to those individual differences, right? Because generally we assume that the individual differences here are zero, right? Because I am observing the same group. If I am observing the same group of people, there's no individual differences, right? There's no individual differences. Whereas here that I'm observing different groups of people, notice that now I can say, okay, this differences can indeed be attributed because of the fact that I haven't, and I do have a difference in the individual characteristics that they possess. So any questions about that? Any questions?